All right, this is the next part to day 5 classwork in our Unit 1 statistics. What we're going to talk about now is how do you find the percent when the z-score is not the same as the standard deviation, okay? So before we had exact. We had 1 standard deviation, 2 standard deviations. It was very straightforward. But this time it is not the same. Oh, what is happening with my thing? There we go. Okay. So a normal distribution in which that symbol mu is the mean. Okay, that is the mean. And this symbol here, I call it sigma, is the standard deviation. And I think they're wanting us to say that the mean is 0 and the standard deviation, I'm going to write this down. Hold on. My thing is behaving very strangely, is 1. Okay? The distribution is standardized by the z-score. Okay? So, like I said, what if it's somewhere in between 1 and 2 standard deviations, or between 2 and 3 standard deviations? All right, because you predominantly do not use this calculator, we're going to skip this. And I'm going to go right to show you how to do it on your calculators. All right, so I have given you a chart. This is where that chart comes into play that I have given you. All right, so we are trying to find the probability. In order to find the probability, we have to know the z-score, okay? So we know when we read the golf scores in a tournament is normally distributed with a mean of 76. So we know the mean is 76 and the standard deviation is 2.6. And this all these problems. Now I want to draw a rough picture, okay? Which is what that calc would do. So here's my normally distributed. I know right down the middle is the mean. Let me draw my line under here. And normally we have 1 standard deviations, 2, 3. 1 standard, 2, 3, okay? From the mean. Now, this one says my z-score is less than 2.1. So if this is 1 standard deviation and this is 2 standard deviations, well, my z-score is going to be somewhere right in this area. And it says less than 2.1. So I need to know how much this whole area is all the way up to that dashed line. Okay? So this is where our chart comes into play. So let me come over here and talk about this number here. When you're trying to find a z-score on the chart, you need to have 1 number in front of the decimal and 2 numbers after the decimal. Well, if I only give you 2.1, then this is the same as 2.10. Okay? These first 2 numbers are the row. This last number in the 100th column, or the 100th place, is talking about the column. Okay? So I'm going to go to my z-score table, and which you can see in front of you. Now, over here to the far left is all the z-scores. These are the negative ones. We have a positive 2.10. So now I'm going to go down to the positive ones, okay? Now, these are the rows. See how there's some number in front of the decimal and 1 place value after the decimal. But then across the top here are the columns that it pertains to, and it looks at the second decimal place or the 100th place. So 0.01, 0.02. So we're looking for 2.10. So I know 0 is the first column. So I'm going to come down here to 2.1. Here's 2.1. And I know 0 is this first column. So the number I'm looking for is 0.9821, okay? All right, so I'm going to go back to this, see if it can come up. So the number I am looking for is 0.9821. Now, when I'm trying to find probability, I need a percent, okay? Which means to go from this to a percent, I am going to multiply this by 100. So my answer is 98.21%. Now, here's something I need you to remember. Okay, if the symbol, okay, in this statement here, if this symbol is less than, and I'm going to write less than because it might not look like this, and I'll show you later what I'm talking about. If the symbol is less than, then you take the percent as is. So then take percent as is. So in other words, this symbol here is less than, Z is less than 2.1, so I'm going to take the percent as is. I do not have to do anything to it, okay? Let's go on to the next problem and I'll show you what we do next. All right, we're using the same mean and the same standard deviation, but because this is already as a z-score, I'm going to use negative 1.50. And now I need to go look in that table and figure out what the number is. But now this time it's greater than, okay? So I'm going to draw a picture. Let's just draw a picture. We do not have to be artists. There is my mean. And I have 1 standard deviation, 2, 3, and 1 standard deviation, 2, 3. Okay, now this is 1.5 going in the negative direction. So I'm going to draw my little dashed line. And this time I want to know all of greater than. All of this. This is my shading right there. Now, when you're looking at your z-table, your z-score table, all of the numbers represent less than. So it's going from left to right, okay? Less than. So we have to now figure out what is greater than, okay? All right, let's go to our z-table and go find negative 1.5. All right, so we're in the positives. Let's go back up to the negatives, and it's negative 1.50, so it's 0.0668. Okay, now let's do this. Let me get back here. So it's 0.0668. Okay, I'm going to multiply it by 100 because I'm going to change it to a percent, and it's 6.68%. Now, 6.68% refers to everything to the left of my dashed line. But I need to figure out how much is on the other side. So the easiest way to do this, and this is for greater than, and I'll write that little note down here too. The whole thing is 100%. But if I take 100% and subtract 6.68, so if I have this whole thing and I take away this piece, my answer is what's left, which is, let me use my calculator, 100 minus 6.68 is 93.32%. That is my answer. So you have to do something when it's greater than, like this symbol right here is greater than. Okay, so here we go. We're going to write us a little note. If the symbol for z-score, only for z-score, okay, is greater than, so this is greater than, So make sure it says it. Z is greater than, so it might not be this symbol, and you'll see in a few minutes. Then subtract from 100. So I maybe shouldn't use this symbol, okay? But in this case, it is, okay? That is why our answer is 93.32, okay? Now, before I get to the last two, because we might have another part just to understand this, let's look at the difference here. This is an X, so this is talking about my data value. So it's not a z-score yet. So what we're trying to find is the z-score that is less than something. So I have to use my formula where I have x minus mean divided by standard deviation. So I'm going to say 74 minus the mean of 76 divided by the standard deviation of 2.6 equals, I'm going to put that in my calculator, 74 minus 76 divided by 2.6 gives me negative 0.77. Negative, well, I'll throw that 0 in there. 0.77, which is perfect because I want one digit in front, two digits behind. So now let's draw a picture, okay? I'm just going to draw a rough sketch. There is my mean. So I know, here's one, here's one. This is somewhere right here. And I'm doing less than, so I need to shade below it. Okay? So this is negative 0.77. So I'm going to go to my table, go to my z-score table. I'm going to find negative 0.77. So there's 0.7, but now I have to go to the column. So I know it's 0, 1, 2, 3, 4, 5, 6, 7. So I know it's 0.2206. Okay, let's go back. So I know it's 0.2206. I'm going to multiply it by 100. And I get 22.06%. Now, do I keep this? Well, when it's less than, that is a less than symbol. Same thing here. When I keep it, this number stays the same. Only time I subtract it from 100 is when I'm doing above or greater than. Okay? All right, the next part will be the last three problems.